Alright, so you've been given a chance to define and train an autoencoder of your own, and I want to show you what training looked like for my simple model. I decided to train for around 20 epochs. I looked at the trends in training loss and saw that the biggest decreases happened at the start of training, and then minor decreases around epoch 14 or so. So if I trained for longer than 20 epochs, I'm not sure I would have seen much of an improvement. But this loss is only one way to check how well your model is doing. For a classification model, recall, we would often look at classification accuracy, but here the task is a little different. This whole time, we're comparing original input images to their reconstructions, so a better way to see how your encoder is doing is to look directly at those reconstructions. Here I'm loading in a batch of test data, and I care only about the images. I then flatten those test images and pass them to our model to get some reconstructions. Finally, I resize this output so that it's reshaped into a 28 by 28 image. And this code displays 10 original images and their 10 reconstructions underneath them. And you can check out the result. For the most part, these reconstructions look pretty good, almost identical to the original images in some cases. But there do seem to be some weird blurry artifacts around the edges and curves of some digits. You can experiment with adding more linear layers to this model, but next, since we know that most image analysis tasks are better done by convolutional layers, let's see how we might create a good convolutional autoencoder.